Okay, here's another example. We're taking the limit as x approaches 2 from the positive side of this expression. I get tired of writing out the LIM every time. However, it's important to know that a limit process is being done to this expression over here, so I really shouldn't leave off writing this part. If we imagine some kind of x approaches 2 from the positive side type of list, we might get something like this. The corresponding x minus 2 list would look like this. Now it's hopefully clear what the x minus 2 should be approaching. The x minus 2 list is approaching 0 from the positive side, apparently. Minus 2 is approaching 0 from the positive side. If I start squaring each term in that list, that means x minus 2 squared list should be going towards 0 from the positive side even faster. And if this list is going to 0 from the positive side, 1 over that should be going to plus infinity from our earlier work. This limit is going to be plus infinity. Now let's look at what happens if we take the limit as x approaches 2 from the negative side, from the left. Here's an example of an x list going to 2 from the negative side. Notice that if you look at the x minus 2 list built from it, that it should be approaching 0 from the negative side. As a consequence, we might notice in passing that that means the 1 over x minus 2 list should be going to minus infinity. Notice, however, that if I take the x minus 2 list and square it, the squaring makes every entry in the list positive. As a consequence, that means the x minus 2 squared list is going to 0 from the positive side, and hence that means that 1 over x minus 2 squared, that list goes to positive infinity. So the limit as x approaches 2 from the negative side of the 1 over the quantity x minus 2 squared is also positive infinity. The side that we were approaching from did not matter. The work above, where I checked both sides, allows me to say that the limit as x approaches 2 of the 1 over quantity x minus 2 squared is going to be plus infinity. Because there's no plus or minus over here, that means that it doesn't matter which side. This could be referred to as a two-sided limit. Here's a sketch of the function y equal to 1 over x minus 2 squared. This was the same function we were just taking the limit of. The limits that we already computed are telling us something about the graph. If we imagine a list of numbers that are bigger than 2, but are getting closer and closer to 2, corresponding to those are going to be points on the graph. I can't even fit those points on my graph anymore. And you notice that as we get closer and closer to 2, the corresponding points are climbing upwards. The y coordinates, those are going to infinity. The statement that the limit as x approaches 2 from the negative side of our function is infinity is another way of saying that when the x's are near 2 but a little bit smaller than 2, the corresponding points are climbing up towards positive infinity. All right, here's a more interesting example. If you graph y equal to x plus the quantity absolute value of x minus 2 divided by the quantity x minus 2, you get something along these general lines, which we've already looked at before. This is a graph that came in two pieces. One piece comes out of the point 2, 3, and the other one out of the point 2, 1. If you have the graph in front of you, then it's pretty easy to say what these corresponding limits should be. If the x's are getting closer and closer to 2 from the positive side, those are x's over here, then corresponding points on the graph are over here getting closer and closer to the point 2, 3. In particular, this gives the y-coordinates. The y-coordinates are getting close to 3. Similarly, if you're looking at the limit as x approaches 2 from the negative side, those go with points on this other half of the graph. And as the x's get close to 2, the corresponding y's are getting close to 1. The obvious question to ask here is there some good way of computing this limit without having to graph the thing first? We essentially have to think through two different cases. In case the number x is bigger than 2, then if you look at the absolute value of x minus 2, because x minus 2 is going to be positive in this situation, that means that the absolute value is just going to be x minus 2. As a consequence, if we look at the complete formula, I can replace the absolute value of x minus 2 with just x minus 2 and simplify and get something quite nice. If x is less than 2, then that means that x minus 2 is going to be negative. When I take the absolute value of that, I need to change the sign from negative to positive, and I can do that with a formula like this one. As a consequence, when x is less than 2, our expression here can be simplified by noticing that x minus 2 can be replaced by minus the quantity x minus 2. And then when we do the division, this part becomes minus 1. The standard way to sum up these results is to note that this formula needs to be dealt with in cases. In the case where x is bigger than 2, the result from the formula is going to give us an x plus 1. In the case that x is less than 2, then the result from the formula is going to be x minus 1. Now we don't need to graph. If I want to compute the limit as x approaches 2 from the positive side, it's understood that the x's that we're working with have to be bigger than 2, so the absolute value of x minus 2 is just the same thing as x minus 2. Do my simplifying, and I have this expression to play with. Maybe I should put the parentheses on here for emphasis. And so the limit is just going to be 2 plus 1, or 3. If we want to look at the limit as x approaches 2 from the negative side, we can say similar sorts of things. After simplifying, our formula just becomes x minus 1 in this situation. And then 2 minus 1, when I plug in, just gives me 1 for the limit, just as before. Finally, we should also notice that the two-sided limit as x approaches 2 from either the left or the right is not defined, since we get different limit values depending upon whether we take our limit from the right or take our limit from the left. In other words, the one-sided limits are not equal to one another, causing the two-sided limit not to exist.